Okay, so let's say we have x and y, x is right here, and then we have some kind of, that's xy, right? When we say xy, that means this is x. I'm going to zoom in a little bit. This is x, and this is y, right? And of course, this is r, and this is theta. So obvious relationship, x is equal to r cosine theta, and y is equal to r sine theta, eh? Well, that is, if you know r and theta, then you can go to x and y. How about the other way? How can you go from x and y to r and theta? Well, r squared happens to be x squared plus y squared, Pythagorean theorem. And also, tangent theta is equal to y over x. That gives you that angle, correct? Well, see, the reason that I didn't want to use inverse tangent is inverse tangent has restrictions, first quadrant, fourth quadrant. But this thing, actually, it needs to be more like a relation, you know what I'm saying? So I wanted to write it this way. So this is nice and easy so far. One little technique I want to share with you is this. If you have r as function of theta happens to be some kind of a sine theta plus b cosine theta, what is the graph of this thing? Okay, let's take a concrete example. And then I'm going to redo this thing. So let's say r of some theta happens to be, let's use the same example in the notes. So 3 or 4 cosine theta. I'm going to do cosine first. I changed my mind. Because for some reason I have it backward, and let's do it like that. That's a little more straightforward. It's easier to understand. So if we have 3 cosine theta plus 4 sine theta. What does that mean? What does it look like? When you're doing that polar graphing quiz, didn't I put some kind of rotated, was it limaçon on it? Yeah, so it's kind of like that. Let's graph it, shall we? Okay. And I'm going to go to polar graphing. So, and zoom in a little bit. So if I graph, was it 3 cosine, right? 3 cosine, then plus 4 sine. Ready? Circle. It's a perfect circle. Okay, I'm gonna copy this thing. To the notes. Okay, let's come here and then deal with this situation. Okay, so we have this. But then do you see this is equation of the circle in polar coordinate is this. R is equal to some radius, right? Some radius, we'll just call it R, and cosine theta, isn't it? But then that is this circle, right? This thing is being rotated by some phase shift. Do you get it? Do you get it? Do you not get it? So it's like, looks like this is our phase shift. And then that distance, do you believe this is 5? Does it look like 5? Yeah, you can count, right? Here's 1, 2, 3, 4, 5. Huh? Do you see it's a rotated circle? How can we figure this out and feel it exactly is my question. Otherwise, polar coordinate, I mean, you should know polar coordinate by now, right? But this is probably something new. Okay, should we figure out how to, well, should we learn how to figure out this We'll call it R for now. How to figure out R and phi is. This R is 5, as you can see, and this is approximately 53 degrees. What? Graphically, let's get the idea. How do I know these things, right? This is 3. 3, 4, 5. Phi is equal to. Do you see that geometrically what it turns out to be? It's a 3, 4, 5 triangle. It turns out. But why? Why? Right? Okay. I'm gonna do this, and maybe I'll do it theoretically. We'll see. So we know that this thing is some kind of, right, constant times some kind of phase shift. Why is that? Well, if we work this out backward, then it makes sense. This is R of, do you see it's cosine plus sine. Do you remember this thingy? Identity? Say yes. So I distribute R. I'm going to write it a little weirdly. I'm going to switch these two. There's a reason. Now I'm going to switch the two. Now, why would I want to write it like that? Then I want you to pay attention to what our original question is, right? Our original R, this has to be 3 cosine theta plus 4 sine theta. Now I want you to compare this and this. You know what I'm saying? You know what I'm saying. So that gives us equations saying R cosine phi is equal to 3 and R sine phi is equal to 4. Good. And can we solve this equation? Suggestion? One way right away is, what about this thing divided by that thing? So if I divide, I get tangent phi is equal to 4/3. Oh my God, right? So phi is inverse tangent of 4/3, and that of course is 53 degrees. You get it? Or how do we get R? Well, like this. You square both sides. So we have 9, and then you square both sides of this, and you get 16. Then of course, guess what I'm going to do, right? Like that. Then this is R squares, cosine square, sine square gives you 1, and this is 25, so R must be 5. So our function, this form, is 5 cosine theta minus whatever, 53 degrees-ish. You get it? Okay, let's look at the theoretical aspect of all of that, and not that we are going to memorize this. So now, remember we started with this? What did I write? A cosine theta. It's a little bit different than what you have in the notes, but hey, whatever. Right? We have this. And then we want this to be same as some kind of R here, and then cosine theta minus phi. Right? Then we expand this out, so we have R cosine plus, and I'm going to distribute R sine. You get it? Then comparing this thingy, see, this thingy must be same as this, and just this thingy must be same as that, right? Because we have cosine and sine. In terms of theta is our variable. So this gives us systems of equation R cosine phi is equal to A, and R sine phi is equal to B. And then like before, take this over this. So you have tangent B is equal to B over A. That's a nice relationship now, isn't it? And then you square and add. So R square cosine phi square phi is equal to A square. And then R square sine square phi is equal to B square. That looks a little sloppy. Then if you add vertically, then you get just R squared is equal to A squared plus B squared, Pythagorean theorem.